Hi, folks. Thanks for coming to this session. We're slowly reaching the end of the Kotlin Conf, so I hope you're not very tired after yesterday. And as you've read, I'll be talking about data analysis for finance using Kotlin. My name is Enrique Lopez Mañas, and I hope if you can learn at least one new thing today, that would be awesome. We'll be talking today about Python, R, Kotlin, what's the differences between them, which language is more apt for data analytics and data science and visualization. We'll be checking the peculiarities from Kotlin. And I'll introduce two frameworks, which maybe you've seen at other talks, or you've talked with some of the folks at JetBrains. DataFrame for data management and data processing, and Kandy for data visualization. Then I'll show you some tricks for financial representation, things that we can do with those libraries. I'll introduce some personal takeaways, and hope you enjoy. How it started for me, I always tried to live at the intersection of computer science and finance. In fact, my bachelor back in time was in economics, computer science, so was basically computer science with a touch of accounting and financial theory. And I ended up doing software development for a living, but I was always interested in, well, the stock market and how the stocks move and how the economy works and how do you buy companies, different financial strategies, selling options, calls, puts, etc. At some point, I started investing in the stock market, managing my little portfolio of companies. Then I used Excel, which I think it works very well. You can get out of the box a lot of information using the Google finance function, like the current stock value, the low or high of a given year. So I started doing charts like this on Google Excel, displaying my portfolio of companies, seeing how the evolution worked through an entire year with the amount of cash I use, the current stock value, the difference between them. I had also a representation of sectors. I try to invest in companies that are very conservative and, they don't give you a lot of positive or negative surprises, mostly positive in the long term. Then sometimes, you also need to see, which companies should I buy now for my small fund? When should I buy them? How do I determine if it's the moment to buy? I try not to sell. And, Excel was working, but I guess as a nice Kotlin developer and nerd, I always was wondering, what can I do which is not Excel and a spreadsheet? And Kotlin was, of course, the immediate choice. So I'll do this statement. It seems to be the accepted truth. The financial data analysis is traditionally dominated by Python, R at a smaller scale, mostly for data visualization, because they have a large ecosystem and they have been ready for many years for processing financial data and presenting it. Now, let's see if the data fits this statement, or we need to change our statement. Of course, I think sometimes we have an idea, we try to find data to see if it supports our idea, and I think it should work the other way around. You should check the data and then come up with a statement. Otherwise, you end up with doing interpretations like this very nice gentleman who happens to work at Philip Morris, and probably not related to that. He thinks that nicotine can prevent Alzheimer, because there is a correlation, right? The more people smoke, the less Alzheimer they develop. But it's not because the nicotine is preventing the development of the disease, it's because it kills you. So that's a good example of correlations. It doesn't imply causality. So we would like to have data like which language people are using for this and run a survey through the entire community of developers. But the reality is that it's sometimes our options are limited, so we need to take data from different places, put it together, and take our own takeaways and interpretations. So according to the TOVE index, which is, by the way, an index that measures the popularity of a language based on searches on search engines. So if people go to Google and type Python or Kotlin or whatever, then this makes the language increase positions on the TIOB index, and this obviously doesn't mean that more people are using the language. So Python has been the top language for the last couple of years, maybe unsurprisingly because of the AI renaissance and, well, people using more AI everywhere. R, surprisingly, is at the position number 12. If you haven't used it, it's a language that is probably niche enough for, well, you probably haven't seen companies using it at a large scale or many companies using it at a large scale doing backend development or front-end development. And Kotlin is on the position 25, which is surprising. You would expect more people doing Kotlin than R. So that's probably what happens. There is this other survey from here, from Stack Overflow, which answering the question of which language have you been using extensively for development work and you plan to use in the next year, then things change a little bit. JavaScript goes to the top because web front-end probably. Then Python moves into the position number 3. Kotlin here goes into a more decent 10% of the user base, and R stays at 4%. If we check the Python usage by year, what people are using Python for, you see that, unsurprisingly, also many folks are using it for data things. Call it data analysis, data engineering, data science. There is some subtle meaning for each of them, but seems to be a language where the data science presence is strong. I think here I took a video. You also have the main usage of the Python usage as a main and secondary language, and you can still see that data is prevalent here. Yeah, what do you use Python the most? Still, web development seems to be, I don't know if surprisingly or not, one of the widest use of Python. You have frameworks like Flash for doing web development, but we still see that data analysis is on the 3rd position. Machine learning sometimes interacts a bit or overlaps a bit with data analysis. So we can probably accept that data is important for Python users. So 48% of all Python developers in this JetBrains survey were involved in data exploration and processing. Now, that was Python. What is R? R is a language used mostly for statistical computing. If you have been studying economics at the university, most of the, I think, courses are using R. It's very strong for doing statistical operations. It gives a lot of facilities to do data modeling, and it's very much focused on creating presentations, plots, reports, where you can generate different charts and create an interactive website that gets automatically published using Quarto. It's one framework for reporting on R. Yeah, it's, well, I think it's the main usage. But you can still do a few things. I found a few weeks ago, actually, that you can create your own blog using Quarto, which for me was surprising. And there is even art generative AI framework for R, where you can, well, use it for computer-generated art. You can initialize some seed, colors, start calling random shapes, and you come up with these very abstract and modern images. In fact, if you want to check how it looks, I have this website here, bikes, newyorkcity.eu, EU because the domain was very cheap. I think I had to pay like 0.99 for 1 year. And here I published a report I did a few weeks ago where I was analyzing the data usage from the public bikes in New York based on the open data that they publish on the website. And well, here you have some code samples. This is generated directly from R. Yeah, you can see the code, and the code is going to generate some charts, and you can see which code is generating what. And you can see here also on the right side that the indexing is automatically done using Markdown. So it's very, very simple for yeah, generating this sort of charts and studies. Yeah, but now let's go to Kotlin. Who knows Kotlin here? Yay. Yeah, you can see, based also on the JetBrains developer ecosystem survey, that data does not seem to be the most common usage of Kotlin. You still have some people answering that they're using it for data processing and science, but it does not seem to be as much as in Python. Now, what do we do with data? And well, we've been checking like data analysis, data science, what it means. It's different word. I like this Venn diagram of we have like three concepts: math and stats, all the mathematical and numeric methods to make interpretation of data. We have computer science, which provide us with the structures and algorithms to deal with this data. And then we have the domain knowledge, the very specific knowledge about a specific topic. Well, according to this, the data analysts sit on the intersection between math and the domain knowledge, and the data scientist is at the intersection of all of them. I also like this diagram from here. I think as people, we have the taxonomic perseverance of a botanist. We try always to put different tags and words and categories on people, like you are this and you're that. And the reality is that there are a lot of gray tones, and things are not black or white. You have a lot of things in between. And well, it seems like somebody focusing on programming would be the hacker, somebody focusing on business would be the accountant, somebody focusing on communication would be the person selling air, the data nerd would be focusing on statistics, and then you have little intersections where you could identify yourself. If you're into programming and statistics, maybe you could be the R core team. So yeah, if you have some interest in data, you're probably in one of those intersections here. Well, let's check a little bit the ecosystem. When it comes to core data, in R and Python, we have already some libraries that are having there for some time. DataFrame at R, Pandas and NumPy at Python. And Kotlin is using DataFrame, which is has been inspired by DataFrame from R. For visualization, R has a few libraries. ggplot2 is the most widely used one. That's the one I used in the example that I showed you before. Python also contains a few, Plotly. And Kotlin has a few of them. Kandy is the one that I'll be talking today, which is inspired by Let's Plot. And we also have Kotlin Plotly, which is another library independently developed, not by JetBrains, by the way. For time series, again, a few libraries at R and Python. Kotlin does not have a library like the ones you find in R or Python, but you can do it manually via the data frame, or of course, you can interoperate with Java libraries or Kotlin libraries, so that problem seems to be solved. For finance, R and Python, and this is one of the strengths, they have libraries that provide a lot of data already, are connecting with different APIs. In Kotlin, again, we can do the interoperability with Java libraries like gquant, flip, external APIs where you can connect and download this data, even if getting data is a problem, and we'll get to that later. Reporting, R uses Quarto, the library I use, or R Markdown. In Python, we have the Jupyter, and well, with Kotlin, which you've probably seen at other talks today or yesterday, there are the notebooks that are awesome and run now on IntelliJ. R is weakly typed and vectorized, so that means that R can, when you pass data to R, is going to be typed, but very weakly typed. That means that if you're passing a string and floats and mixed data, it's going to try to take the minimum common denominator to all of them, and very much everything is a vector. Python is dynamically typed, as we know, and as we also know, Kotlin is statically typed. And well, the IDE support R contains RStudio, which very briefly, if I'm not sure if you've checked it before, well, you know Android Studio and IntelliJ and the JetBrains frameworks. They are very similar. On the left, you have files. Then you have on the right the code. At the bottom, you have like different login screens or performance panels. RStudio is very focused on data. You can see that here you have this environment where all the data is being loaded. You can click here, start operating it with it. So you can see that it's very much focused on loading large sets of data and dealing with it. And then you have here lots of tools for data visualization and generating diagrams and stuff. Python has PyCharm, VS Code, and in Kotlin we can use IntelliJ IDE and then the Kotlin notebooks. Again, not all statistics are relevant, but I like to use Google Trends from time to time. If you search Python pandas, ggplot, and Kandy Kotlin, which are the main charts libraries for each language, you see that, well, Python sits at the top, ggplot right after, and then Kandy right under it. But why Kotlin? Well, you're attending the Kotlin Conf, so you know already why Kotlin is awesome. You have your own opinion about it. It has a fantastic tooling. You've probably been using it for backend. It's, in general, the developer experience and happiness level is really high. But should we be using Kotlin if we already have Python or R? Well, this is a personal opinion and disclaimer. I think it depends. There are no silver bullets and no problems where you say this is the only solution for this problem and you should not think about anything else. In general, as developers, I think we're very orthodox very often, and we are just focused on our thing. And we are reluctant to sometimes accept external ideas. For personal reasons, I've been talking a lot the last weeks about whether apps should be written in React Native or Kotlin multi-platform or native. And the reality is that everybody has different opinions. There are some factual truths that, you can present. But React Native can work for an app. Kotlin multi-platform can work for an app. It's going to depend on many different parameters, factors. Sometimes not all of them are under your control. So you need, as an engineer and somebody trying to solve problems, to get all those different parameters, weigh them, see what's going to be more important in your use case, and take a decision. So Kotlin can be used, I think, for data science if those parameters are serving your purpose. This is the starting kit that you can have for Kotlin data visualization. DataFrame for data management, Kandy for plotting and drawing charts. You also have plotly.kt, not developed by JetBrains, but also a really nice contender, and Kotlin notebooks. Let's do a short introduction to DataFrame. DataFrame has been inspired by pandas and DataFrame from R. It uses type columns with schema inference. That means that each column is going to have a type based on the data that you're passing. It can infer it from the schema, so you don't need to do it manually. It has type-safe column access, meaning that if you're trying to access the name of a column and that name doesn't exist, you're going to get an error on the environment, and hence you're going to be avoiding a runtime error, which is cool. You have, of course, IDE support via autocompletion, and you can read from CSV files, JSON files, SQL files, and Kotlin objects. Hello world of data frames. You can see here what we have is we're reading a data frame using this read CSV file function. We specify a file or URL. This is also nice because you can have the file either locally or host it somewhere on GitHub or a different URL. You can specify a few options like the watch between different objects in the CSV file, if you want to use any parser option. And then calling this head function over the data frame is going to present the 5 first different items. So you can see that we have here, the passenger class, whether they survive or not, name, sex, age, etc. But now let's do finance. When it comes to deal with data, the workflow is something like this. We first import the data. We need to tidy it and organize it a little bit. Sometimes the data might not be clean, so you need to start making some groups and cleaning the rows that you're getting, adjusting types. Then you start, transforming them, visualizing them, and at the end, telling the story you want to tell, very often changing your mind in the process, because the data tells something different than you were expecting. Now, let's take a finance example. This is one of the samples from JetBrains. So here in this section, we're importing the latest descriptors and the latest DataFrame and Kandy version. DataFrame, by the way, is 1.0 since Monday or Friday, I think. There was a change that broke my demo, but now it's moving towards stability. And it's as easy as this. In this example, we are going to read this file from here, the top 12 German companies by capitalization. We are calling the rename to camel case function, And they're going to rename these two columns from here, the return over the assets and the return over the equity. The return over the assets is how much money a company is doing over the assets they have, how efficiently they're using them. And the return over equity is how well the company is using the shareholders' money. Yeah, when we have imported it, we can call head, and we're going to be presented with something like this. We'll have the, you can see that we have here the company period, blah, 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 and the ROA and ROE have been renamed based on this block of code from here. Let's do a few more things. We can now import these the date time from Kotlin. We're going to create this local date formatter to change the format into the month/day/year/. We're going to have this helper enum, where we add several business sectors. So automotive, in Germany, many companies are working in the automotive industry, banking, industrial tech, etc. And let's do some more transformations. So here we are getting our previous data frame. We are going to convert the period column into the local date format that we specified. We are going to convert the percentage debt to equity by removing this percent suffix at the end, and we're going to replace the comma with a dot, and we're going to convert it to double. Then we'll sort it by company first and period second. And we're going to add one more column on real time. This column is going to be called sector, and depending on the company, is going to be one sector or another one. For example, for Volkswagen, BMW, and so on, is going to be automotive. For Allianz, it's going to be insurance, and so on and so on. So now, yeah, we have this data frame. You can see here on the right side that we have a new column called sector. Let's do more operations. Now, we are going to group by company. Similar to how you would do an SQL query. And now we're going to aggregate several columns at once. We'll take the columns, all the columns, basically revenue, net income, liabilities, etc. And for each of those columns, we are going to call the mean, the median function, the standard deviation, minimum, and maximum. And here I did a video. I have it also locally, but you can see that we have like some groups here. So for median, we have the median information for all the the companies, the standard deviation as well, and well, we're slowly preparing our data for visualization. Same for sector. So yeah, we're going to do the same, but this time for sectors. So now what we have is a similar data frame, but see that now what we have on the first column is the sector instead of the company. So how much revenue the companies in insurance and automotive and so on are having. OK, we've been preparing and managing a little bit our data. Now it comes to data visualization. Let's use Kandy, and let's talk Kandy. Kandy is cross-platform. Cross-platform in this context doesn't mean Compose and iOS. It means that, well, we can run it in IntelliJ and Datalore and Jupyter. It provides interactive charts, which we'll see later on the environment. And it's inspired by a book called The Grammar of Graphics. It's, I think this book is really nice because it's focusing on, I'm not related to the book, of course, but it talks about not just the type of charts that you have, because well, you can read that anywhere else, but about what makes good data representation good. When should you truncate data? When should you give the data order? Should you sometimes, when should you use logarithmic versus linear progression, etc.? So I think it gives nice tips on more behavioral about the representation of data. So yeah, let's say we have this company data frame that we had from before. We're going to generate a different data frame for time series. So in this case, we're going to take the period and the sector. We're going to aggregate by the sum of the total revenue and by the total net income. Already we're having here a couple of helper structures, the list of sectors, and the list of sectors colors. So see that now we're calling the plot function. This plot function is receiving a lambda here, where we specify what's going to be on our x-axis, the horizontal one. We're going to have our period. Generally, the time representation goes on the horizontal axis from the left to right. Then we're going to have the total revenue on the vertical axis, and then we're going to be drawing several lines, actually. So we'll be using the specific color for a sector. We are using a categorical scale where we are passing a range and a domain. And then we need to have a legend to specify what it's going to be the legend for each of those lines that we're drawing. We can also specify things like how large does the points need to be in the chart, or the color that they're going to have, and the layout, which title are we going to have, and the size. The size is important because we'll see later also that by default they can be small, and sometimes data or the axis can get large. So we end up with something like this. If I open this on IntelliJ, this is here on top German companies. Here you can see that it's interactive, actually. So if I'm moving, you see that as you are hovering with the mouse, you can see what each of those points is representing. And you actually can export this chart as an HTML or a PNG or a SVG. You have different options for the format. If we can here and do right-click, save plot as, you can here specify the format that you want, and color scheme, and that's it for now. Good. Then, let's do a couple of things more. We can create a data frame for the return over equity and return over assets. So in this case, grouping by sector, we're going to aggregate, and we're going to get the average ROA and the standard ROA, same for the return on equity. And we're going to do another plot in this case. We are going to have a bar plot. The x axis, the horizontal axis, is going to be the sector of business. Then we're going to specify the bars. See that also we are specifying the scale in case we want to truncate it or have a different representation. Line ranges also with what's the maximum. So we're going to have the average one, but then we're also going to have the minimum and maximum one on a line. You'll see it in a second. And layout for title and size. Here you can see that we have for the insurance the average ROA, and we can see also what's the minimum one at the maximum one. So this can help you to which companies might have like more deviations from the standard one, or be more stable. More charts with Kandy. I'm a bit scared because this is on the here, but I was running everything, and I guess it should work. Yeah. Is it okay visible? Yeah, great. Okay, so let's do more financial operations. I downloaded some data, and I was using some data I had. So here we're going to be displaying a few charts for Coca-Cola as the stock. First, we're going to be loading the daily Coca-Cola values. I have this daily que yo. Exactly. Here I have the daily value for Coca-Cola since 2000 something, since long ago. And we can see that if I run this, it's going to take this file, and it's going to present here the last 5 items. You can actually change it if you want. You can pass 10, and then here is going to be more. And you can also do things like describe the entire data frame. So here what we get is, okay, we have the column timestamp, which is going to be this type. We have close, which is a double. This is the count we have. It's automatically giving the mean value, etc. And I think we also have a schema if we want to. We get like just the data types. Now, this has been loaded. So now let's gonna draw a plot, a very simple one. In this case, we're just calling this function here with line, and specifying the timestamp and close. And here you can see again that this is the chart. Does anybody know what happened in approximately 2012 with Coca-Cola? Yeah, so this is a stock split. Sometimes companies, they say, okay, my stock is 100 euros per stock, so we're going to make a 2-to-1, and then it's going to be 50. So now we have, or the other way around. And in this case, I think it moved from 80 to 40 approximately, so they did a 2-1 split. But nothing really bad happened with Coca-Cola. This is sometimes problematic because if I download this data from the developer relationship page from Coca-Cola, they don't include the split adjustment. So it can be that it's somehow resulting in strange charts. And Google Finance, for example, they reflect the split adjustments. But sometimes this is something that you need to do it manually, maybe with pre-data processing. And you can also change the width of the lines or the color. Here is going to be red, and the size of the charts if we want to make it a little bit wider. Now let's actually this I'll do this first, and let's do a candlestick. A candlestick basically gives you, for a given stock in a given day, what was the top price, lower price, so you can see how much variation was in a single day. So if we try to run this with all the data that we have, it's absolutely meaningless, because you can see it's, we cannot see anything. But we can call the head function, for instance, and just call in the last 20 items. And in this case, becomes a little bit more meaningful, right? We can see the candle and the top and bottom, the high and low values from a given stock. We also have ribbons. Ribbons are this chart from here, where maybe can adjust a little bit more so it's more visible here. Let me maybe adjust the. Okay, I think that's good. If I. No, this is absolutely meaningless with a stock split. Well, you see, you have the highest value, the low value, and in between you have this area surface. So it's good for when you want to visualize this type of area between two different values. You can also change the style. So in this case, we have it dust, but we could have it dot, for instance. And if I rerun this with, it's going to look like this. We can also do it with a little bit less, and here we see that there are dots instead of the dashes. Now, let's do more things. Dividends, for example. Here we have the dividends from Coca-Cola. I have this file from here. Dividends are a little bit easy, right? This is the dividend per year. I took it only until 2013 because the data I got was not normalized to reflect the stock split. And this is the evolution of how the dividend at Coca-Cola works. You know, companies, there is this concept of dividend kings, companies that are increasing the dividend every year. So you can be reasonably sure that in 10 or 20 years, you're going to be getting more dividends than you get today. So we load this. We make the head here to make sure that everything is all right. And here, I'm going to draw a more complex chart, which is called the Geraldine Weiss band. The Geraldine Weiss band is this chart I saw here. It showcases the combines the stock evolution with the average top yield, the average bottom yield. You can use some percentiles also, like the 95% top dividend yield for the given dividend that has been paid. And the current value of the stock, that is either the one at the top or the one at the bottom, to represent if a stock is overvalued or undervalued. So you can take decisions like, okay, this stock now is historically cheap compared with the yield that it has been having for the last years, and now maybe it's a good time to buy or not. So here what we're doing is getting a data frame with the dividends by year. The code is published, so you can check it later. We calculate the average price per year. The Geraldine Weiss band can be done on a weekly, daily, yearly basis, so depends a little bit on what's your purpose. We are going to calculate also the dividend yield per year on a yearly basis. And then we'll use a percentile to determine the yield that we want to observe. In this case, we're having the 95% for the lower band price, the 5% for the upper one, and then a fair one, which is going to be 50%. So the standard yield for the company. Yeah, to calculate this is a conversion here, to calculate the bands. Then we get the final data and the plot, where we're having a step chart reflecting the lower range, the fair range, and the upper range. So you can see them here. And then finally, a line representing the price of the stock. So you can see now Coca-Cola on a yearly adjustment is probably close to being overvalued, but sometimes, I think in this example, this is for Merck, would be different, right? I think this is probably on a weekly basis. Merck, for example, right now would be really undervalued. Yeah, a couple of charts more that we can do. A portfolio distribution, we have here this, I took this from my portfolio, so this is the company I have in percentage. Allianz 3-point-something %, Apple 1.5. This one is simple. We just load up. This is with, OK. It's still working, but the previous one was deprecated because it was not camel case. We can call this by function, specifying what each of those slices is going to be, the fill color, and then a few parameters like size, whether we're using a hole or not. So here, if I do 5, then the hole is going to be a little bit larger. If I use 0.1, then it's going to be smaller. The alpha that we want, and the style. So here you can see that we have this interactive chart with all the companies of my small fund. Sector representation, also simple one. Here we have you have generally the super sectors, the cyclical ones, sensitive and defensive, and then you have subsectors. But for the super sectors, using the same pi function, we can create another chart that has this legend here, specifying what each of those slices mean and what's the representation percentually for each of them. Dividends. So my favorite topic. I have this dividends by month CSV file, which contains the hypothetical dividends being paid by portfolio since the year 2012. Dividends tend to grow over time. You sometimes want to see how well your portfolio is doing and how much the dividend is growing on a year-to-year basis to see if, am I moving in any direction? Am I moving forward? Am I having any trouble in any given month? And the first approach could be something like this. We can have loading or gathering using this gather function. This function takes a first column and a set of different columns and groups all the next columns coming in. So that's why we're specific. First is the dividend, then we are grouping all the upcoming years. We will be grouping by year, generating the plot, and we're going to be having this bar chart from here, which is very hard to read because we have a lot of content and the chart by default is not so big. So if I uncomment this line and rerun the Kotlin notebook, then we can see that now it's more decent. And if we start moving at January, we see that, OK, the first year somebody got 98 euros, and now it's slowly, after 10 or 13 years, you see how they are growing. And it's, I guess, nice to have a graphical representation about it. Still, the colors here are a little bit manual, right? So we can use this categorical function from here, where we are passing some color pairs, or we can use this categorical color viridis. This is a function from Kandy, which generates this color schema, so you don't have to specify colors manually. OK, then coming back here. We have anyway a lot of charts with Kandy. Time is limited. We can show them all, but you have things like, when it comes to lines, a lot of them. You can have like line with points, simple lines. We also have bars. We can have like horizontal bars, vertical one. We can have stacked bars as well, functional bar plots, area charts also, combining them with other ones, points, error bars. So it's, I think, in that sense, the library provides really a lot of support. There is even support for geographical charts, which is, you can draw your map of the states in the United States and figure out what's happening in each of them. Finance APIs, as mentioned, I think one of the challenges is getting data that is correct and that it has been adjusted to everything and it works. Most of the APIs don't work 100% good. Yahoo used to be one of the best ones. Now, a few years ago, they restricted access. I think right now you can't really use it. NASDAQ is nice. If you go to the NASDAQ website, nasdaq.com, you have something like the historical here. You can click on download historical data. So I guess for NASDAQ data, it's probably good enough. Alpha Vantage, I use that one to download the daily from Coca-Cola. So it's not adjusting by splits, but I think it's still OK. Morningstar and Quandl are two other ones that are being used. So but again, I think ultimately you sometimes need to do sanity checks with the investor relationship page. That's super easy. If you do something like investor relationship Coca-Cola, or well, most of the companies, you'll have websites like this where you can download and check if the financial data is correct or not. Well, more Kandy. We already talked a little bit about Kandy. Well, we've seen as well the Kotlin notebooks. For me, explain me like I5. Kotlin notebook is a notepad for Kotlin programmers. You write code in Kotlin, you see the results right away. They don't have too much functionality because they don't need it. You can split different cells here, and then here you can start writing like something completely unrelated to the other ones. They run independently, and you don't need to set up a lot of things locally. Maybe for Kotlin developers, it's not that bad, but imagine Python developers. Should I install PIP3 with a brew or with a apt-get? Or we have Datalore, which is a fancy online notebook from JetBrains. And I actually wrote a month ago this article about vibe coding and, well, Kotlin and finance and data visualization. I'm not going too much into the details, but the article is live if you want to check it. I saw somebody claiming from a fund on a newsletter that, oh, now everybody can program with AI. So I'm going to be using, we have two different portfolios. One of them is performing better under certain conditions. 90% of the times it's better. I just did this with Gemini API. The code compiles, and it's correct. So, well, I saw the exact problem a few years ago, and I knew that it was not 90%. It was like more like 2/3 of the time one portfolio is performing better than another. And I created this Datalore, this notebook, and the guy was basically checking for a portfolio that goes grows more on a bull market than goes down on a bear market. This guy was claiming this thing about performance, and the thing is that I ran this using a different approach. I got this, this portfolio is better in 62% of the time. This portfolio is better in 90% of the time. The thing is that this guy was generating the code via Gemini API, and Gemini was using two different random number generators for his approach. So he was running the same sequence to compare the portfolios, creating a Monte Carlo simulation over totally different time sequences. So of course, things are going to be very different because you cannot compare them. You need to use exactly the same random generator. So be careful when using AI, because this guy's probably taking multi-billion decisions from his fund, and nobody's checking what he's writing. Anyway, some takeaways. We've seen type system in Kotlin is static, Python and R dynamic or with dynamic. The tooling ID is, I think, in my opinion, excellent for IntelliJ. Python, unless you're using PyCharm, it's OK. And R, it's OK, very focused on data. Visualization, Python and R seem to have very solid options. Kandy is growing, but I think it covers most of the use cases. Community data libraries for Kotlin, it's still emerging. Python and R seem to be mature. Performance seems to be better at, in general, Kotlin, medium at Python. The thing with Python is that it's been traditionally slower, but Python sometimes is using C++ libraries underneath and just using a Python interface to access them. Like I think is the case for pandas. So some people claim, yeah, Python is really quick. Of course, if you're using a C++ library, it's quick. And the learning curve may be something subjective. Python is generally claimed as the easiest language to learn. Kotlin a little bit harder, but that's going to be always a personal one, and R more moderate. Integration, of course, with Kotlin. Imagine if you have your backend in Kotlin, or it's very easy to integrate with R. R only can integrate with R because there are no things with R, and Python has also moderate integration. So we're finishing. Again, a personal opinion. There are no silver bullets, and you always need to see what's going to fit your use case. If Kotlin makes it because many different parameters, you should be using Kotlin. If not, Python. That's always a very personal decision that nobody can take for you, or just making a plain statement. Just some links for you. DataFrame, Kandy, Plotly, the library. The data lore I saw was using Plotly instead of Kandy if you want to compare how the two libraries were, but they're very similar. Kotlin for data analysis, there is this documentation page at the Kotlin Lang website where you can read a little bit more. The data science on the Kotlin Slack is a great one. My code, it's in this URL from here, the GitHub repository. You can clone it and see and check it if you want. And these here are the very same slides you saw today. If you have some time for feedback, I would greatly appreciate it. Is there something that you didn't like, something that you would have liked to see more, something that was not in the slides that you think it should have been seen? Please, it takes 1 minute, just give me your comment, and that will help me to, be more mindful of what I should be talking about next time. Thank you. Don't forget to vote on the app for the sessions. And if you have any question and I happen to know the answer for that question, feel free to ping me or find me around the venue, or I'll be here for a little bit. Thank you.